SQL Theory in Reverse Order, Episode 1. Title: Learn SQL in reverse order. Vertical bar. Think like a senior data analyst before writing any SQL. Introduction. Welcome to our SQL in reverse order series. Most people begin SQL before writing any SQL. Introduction. Welcome to our SQL in reverse order series. Most people begin SQL by memorizing commands like select, where, and join. But that's not how experienced data analysts work. Professional analysts start with a business problem. Only then do they decide what SQL query to write. In this series, you'll first learn how experts think. After that, SQL syntax will become much easier to understand. What is the real job of a data analyst? A data analyst does not get paid for writing SQL. A data analyst gets paid for solving business problems using data. SQL is simply a tool that helps answer important questions. For example, which products generate the most profit? Why are sales dropping? Which customers are leaving? Which marketing campaign performs best? These are business questions. SQL helps find the answers. How senior data analysts think. Experienced analysts usually follow this process. Understand the business problem. Decide what information is needed. Identify which tables contain the data. Think about how the tables are related. Decide which filters or calculations are required. Write the SQL query. Verify that the results make sense. Present insights and recommendations. Notice that writing SQL comes almost at the end. Thinking comes first. The Data Analyst Mindset. Whenever someone asks a question, don't immediately think, what SQL command should I write? Instead, ask yourself, what is the actual business problem? What information will answer it? Where is that information stored? How should I organize the data? What decision will be made using this answer? This mindset separates beginners from professionals. Example. Imagine your manager asks, our sales have dropped this month. Can you investigate? A beginner thinks, I need to write a SQL query. An experienced analyst thinks, which month's sales should I compare? Which regions are affected? Which products are responsible? Is this due to fewer customers or smaller orders? Has anything changed recently? Only after answering these questions does the analyst write SQL. Why companies use SQL? Companies collect massive amounts of data every day. Examples include customer information, orders, payments, website activity, product inventory, employee records. SQL helps retrieve exactly the data needed to make informed decisions. Without SQL, finding useful information from millions of records would be extremely difficult. Skills that make a great data analyst. SQL is important, but it is only one skill. Great analysts also have curiosity, logical thinking, problem-solving ability, business understanding, communication skills, attention to detail, Learning these skills alongside SQL will make you a stronger analyst. Key takeaways. SQL is a tool, not the final goal. Business problems come before SQL queries. Professional analysts think before they code. Every SQL query should answer a meaningful business question. Hello. If you found this lesson helpful, please like the video, subscribe to the channel, and share it with anyone learning data analytics. Question of the day. If you could become a data analyst at any company, which company would you choose and why? Write your answer in the comments. I'd love to read your responses. In the next episode, we'll learn one of the most important concepts in SQL, the order in which SQL actually executes behind the scenes, which is completely different from the order in which you write it. SQL Theory in Reverse Order, Episode 2. Title: The Biggest SQL Secret: SQL does not run in the order you write it. Introduction. Welcome back. Today, we are going to learn one of the most important SQL concepts that beginners often miss. Most people think SQL executes from left to right, exactly as they type it. That's not true. A database follows its own execution order, and understanding this order makes SQL much easier to learn and debug. Why this matters? Imagine you are following a recipe. You may write the recipe in one order, but while cooking, you naturally prepare ingredients before serving the food. SQL works the same way. You write the query in one order, but the database processes it in a different order. Once you understand this, complex SQL queries become much less intimidating. The actual SQL execution order. The database generally processes a query in this order. From find the tables that contain the data. Join combine related tables if needed. Where remove rows that don't match the conditions. Group by create groups of similar rows. Having filter those groups. Select choose the columns to display. Distinct remove duplicate results if requested. Order by sort the final output. Limit or top fetch depending on the database, return only the required number of rows. Although you usually write select first, the database doesn't start there. Think like the database. Imagine the database asking itself these questions. Which table should I use? Do I need to combine any tables? Which rows should I keep? Should I group similar rows? Should I remove any groups? Which columns should I show? Should I remove duplicates? How should I sort the results? How many rows should I return? Thinking this way helps you understand what the database is doing behind the scenes. A real-world example. Suppose your manager asks, show the top 5 products with the highest sales this year. The database doesn't immediately display the product names. Instead, it first finds the sales table, filters records for this year, groups sales by product, calculates totals, sorts the totals from highest to lowest, returns only the first 5 products. This logical process explains why SQL has a specific execution order. Common beginner mistakes. Many beginners memorize SQL keywords without understanding the workflow. Think select runs first. Confuse where and having. don't realize filtering usually happens before grouping. Understanding execution order helps avoid these mistakes. Key takeaways. SQL is written in one order but executed in another. The database always works logically, step by step. Knowing the execution order makes learning joins, group by, and advanced SQL much easier. Strong SQL skills come from understanding concepts, not memorizing syntax. Question of the day. Imagine you are the database. Which step do you think is the most important, from, where, group by, or order by? Tell me your answer in the comments and explain why. Next episode. In the next episode, we'll explore why some SQL queries are fast while others are slow, and learn the theory behind SQL optimization without writing a single line of code. SQL Theory in Reverse Order, Episode 3. Title: Why some SQL queries are fast and others are slow. Vertical bar SQL Optimization Theory for Beginners. Introduction. Welcome back. Have you ever wondered why two SQL queries that return the same result can take completely different amounts of time? One finishes in less than a second. Another takes several minutes. Today, we'll understand the theory behind SQL optimization. Don't worry, we won't write any SQL code. We'll focus on how the database thinks. What is SQL optimization? SQL optimization means finding the fastest and most efficient way to retrieve data. Imagine you're looking for a book in a library. If the books are arranged properly and there's an index, you'll find it quickly. If every book is scattered randomly, you'll have to search one by one. Databases work in a similar way. How a database searches for data. When a query is executed, the database has two main choices. Search every row in the table. Use a faster path to find only the required rows. The database always tries to choose the most efficient option. Table scan. A table scan means checking every row in a table. Imagine searching for one student's record by reading every page in a school register. This works for small tables. But what if the table contains 100 million rows? Searching every row becomes slow. Index, the database's shortcut. An index is like the index at the back of a textbook. Instead of reading every page, you look up the topic in the index and jump directly to the correct page. Similarly, a database uses indexes to locate data much faster. Indexes improve search speed but also require storage and maintenance whenever data changes. Why queries become slow? A query can be slow for several reasons. The table contains a huge amount of data. There are no useful indexes. Too much unnecessary data is being retrieved. Multiple large tables are joined together. The database has to sort or group a very large number of rows. The query performs unnecessary work. Even a well-written query may become slow if the underlying data is very large. The database optimizer. Modern databases include a component called the optimizer. Think of it as a GPS. When you enter a destination, the GPS chooses the fastest route. Similarly, the optimizer examines different execution strategies and selects the one it estimates will be the most efficient. Its goal is to reduce the amount of work needed to answer your query. Why business understanding matters. Suppose your manager asks, show sales for one customer. An inexperienced analyst might retrieve all customers and then search manually. An experienced analyst asks, which customer? Which time period? Which sales table? What exactly needs to be displayed? A clear business question often leads to a faster and simpler query. Common beginner mistakes. Beginners often retrieve every column even when only a few are needed. Ignore how much data is being processed. Assume the database is always fast. Forget that performance matters when tables grow. Understanding how databases work helps you avoid these habits. Key takeaways. SQL optimization is about reducing unnecessary work. Table scans read every row and can be slow on large datasets. Indexes act as shortcuts to find data quickly. The optimizer chooses an efficient execution plan. Thinking before writing SQL leads to better performing queries. Question of the day. Imagine you have a table with 100 million rows. Would you rather A. Search every row, or B. Use an index to jump directly to the matching rows? Comment A or B and tell me why. Next episode. In the next episode, we'll learn database design theory, how tables are organized, why primary keys and foreign keys matter, and how good database design makes SQL easier to write. SQL Theory in Reverse Order, Episode 4. Title: Database Design Theory Vertical Bar: The Secret Behind Every SQL Database. Introduction. Welcome back. Before learning advanced SQL, you need to understand how databases are organized. Think of it this way. You can't find clothes quickly if your wardrobe is messy. Similarly, SQL becomes difficult when data isn't organized properly. Today, we'll learn how databases are designed and why good design makes data easy to manage. What is a database? A database is an organized collection of related information. Instead of storing data in notebooks or spreadsheets, companies store it in databases. Examples include customer details, employee records, product information, orders, payments, student records. A well-designed database helps businesses store, update, and retrieve information efficiently. What is a table? A database is made up of tables. Think of a table as a spreadsheet. Each table stores one type of information. For example, customers table, products table, orders table, employees table. Keeping different types of data in separate tables makes the database easier to maintain. Rows and columns. Every table has rows. Each row represents one record. For example, one customer or one order. Columns. Each column stores one type of information, such as name, email, price, or order date. Rows answer who or what. Columns answer which detail. Primary key: the unique identity. Imagine a classroom where every student has the same roll number. It would be impossible to identify the correct student. That's why every table usually has a primary key. A primary key uniquely identifies each row. Examples: student ID, Customer ID, Product ID, Order ID. No two rows should share the same primary key. Foreign key connecting tables. Different tables often need to communicate. A foreign key creates this connection. For example, the orders table stores a customer ID. That customer ID points to the correct customer in the customers table. Instead of repeating customer details in every order, the database simply stores the link. This reduces duplication and keeps the data consistent. Relationships between tables. Tables are connected through relationships. The most common relationship is one customer, many orders. One customer can place many orders, but each order belongs to one customer. Other examples include one teacher, many students. One department, many employees. One category, many products. Understanding relationships is essential because SQL joins use these connections. Why we don't store everything in one table. Imagine a single table containing customer details, product details, employee details, payment details, delivery details. It would become huge, repetitive, and difficult to update. Instead, databases divide information into separate tables connected by keys. This makes data cleaner, faster, and easier to manage. What is normalization? Normalization is the process of organizing data to reduce duplication and improve consistency. Its goals are: avoid repeated information, save storage space, prevent mistakes, make updates easier, improve data quality. Think of normalization as organizing your wardrobe. Each item has its own proper place. Real-world example. Consider an online shopping website. It may have separate tables for customers, products, orders, payments, deliveries. Each table has a specific purpose, and they are connected using keys. This organized structure allows the business to manage millions of records efficiently. Key takeaways. A database is a collection of related tables. Tables store one type of information. Rows represent records. Columns represent attributes. Primary keys uniquely identify each row. Foreign keys connect related tables. Good database design makes SQL easier and more efficient. Normalization reduces duplication and keeps data organized. Question of the day. Imagine you are designing a database for a school. What tables would you create first? For example, students, teachers, classes. Share your ideas in the comments. Next episode. In the next episode, we'll learn join theory, how databases combine information from multiple tables and why joins are among the most powerful concepts in SQL. SQL Theory in Reverse Order, Episode 5. Title: SQL Join Theory explained vertical bar, the most important SQL concept without writing code. Introduction. Welcome back. Today, we'll learn one of the most powerful concepts in SQL, joins. Many beginners think joins are difficult because they focus on syntax. But the real secret is understanding why joins exist. Once you understand the idea, writing join queries becomes much easier. Why do we need joins? In the previous episode, we learned that databases store information in separate tables. For example, customers, orders, products, payments. This keeps the database organized. But businesses often need information from more than one table. For example, which customer bought which product? Which orders have been paid? Which employee handled each order? The answer is joins. A join combines related information from different tables into one result. Think of a join like solving a puzzle. Imagine you have two puzzle pieces. One piece contains customer information. The other contains order information. Individually, they tell only part of the story. When you connect them, you see the complete picture. That's exactly what a join does. The common link. How does the database know which records belong together? It looks for a common key. For example, customer ID, product ID, employee ID, order ID. These matching values allow the database to connect related records. Without a common key, the database doesn't know how the tables relate. Inner join. An inner join returns only the records that exist in both tables. Imagine two friend groups. Only the people who belong to both groups are invited to a special event. This is the most commonly used type of join. Left join. A left join keeps all records from the left table. If matching data exists in the right table, it is included. If not, the left side record still appears. Imagine a class attendance sheet. Every student appears, even if some students were absent. Right join. A right join is the opposite. It keeps all records from the right table, whether or not matching data exists on the left. Although useful, it is used less frequently because many developers simply reverse the table order and use a left join. Full join. A full join returns everything from both tables. Matching records are combined. Non-matching records from either table are also included. Think of inviting everyone from two different clubs to one large event. No one is left out. Cross-join. A cross-join matches every row from one table with every row from another table. Imagine 5 students times 4 subjects. The result is 20 possible combinations. Because the number of rows grows very quickly, cross-joins should be used carefully. Self-join. A self-join connects a table to itself. This is useful when rows inside the same table are related. For example, an employee table may contain both employees and their managers. Since managers are also employees, the database compares the table with itself. Which join is used most? In real business projects, inner join is used very frequently. Left join is also very common. Right join is less common. Full join is used only in specific situations. Cross join is rare. Self-join is useful for hierarchical data. Understanding when to use each join is more important than memorizing definitions. Real-world example. Imagine an online shopping company. The manager asks, show the customer's name, the product purchased, and the payment status. This information is stored in different tables. A join allows the database to combine all the related information into one meaningful result. Without joins, answering this question would be almost impossible. Key takeaways. Databases store information in separate tables. Joins combine related information. A common key connects the tables. Different join types return different sets of data. Joins help answer real business questions by bringing data together. Question of the day. Which join do you think companies use the most? A. Inner join. B. Left join. C. Full join. Comment your answer and tell me why. Next episode. In the next episode, we'll learn aggregation theory, how SQL summarize data using concepts like totals, averages, minimums, maximums, and counts, all without writing a single line of SQL code. SQL Theory in Reverse Order, Episode 6. Title: Aggregation Theory Explained Vertical bar. How companies turn millions of rows into business insights. Introduction. Welcome back. Imagine a company has 50 million sales records. Does the CEO want to read all 50 million rows? Of course not. The CEO wants answers like: what were the total sales this month? Which product sold the most? Which city generated the highest revenue? What is the average order value? This is where aggregation comes in. Aggregation means taking a large amount of data and summarizing it into meaningful information. What is aggregation? Aggregation is the process of combining many records into a single summary. Think about your school report card. Your teachers don't show every mark from every class activity. Instead, they calculate total marks, average marks, highest marks, lowest marks. That's aggregation. Why businesses need aggregation? Businesses don't make decisions using individual records. They make decisions using summaries. For example, a supermarket manager doesn't check every receipt. Instead, they ask: total sales today, best-selling product, number of customers, average bill amount. Aggregation transforms raw data into useful business information. The 5 most common aggregations.
1.
Count. Count answers. How many? Examples: how many customers? How many orders? How many employees? It measures the number of records.
2.
Sum. Sum answers. What is the total? Examples: total sales, total profit, total salary paid, total quantity sold. It adds values together.
3.
Average. Average answers. What is the average? Examples: average salary, average marks, average order value, average customer rating. Averages help businesses understand typical performance.
4.
Max. Max answers. What is the highest? Examples: highest salary, highest sales, most expensive product, highest exam score. It identifies the maximum value.
5.
Min. Min answers. What is the lowest? Examples. Lowest salary. Cheapest product. Lowest temperature. Minimum order amount. It identifies the minimum value. What is group by? Imagine a teacher wants the average marks for each class. Instead of calculating one average for the whole school, the teacher separates students into groups. Class 6, Class 7, Class 8. Then calculates the average for each group. That's the idea behind group by. It divides data into categories before calculating summaries. Businesses use grouping constantly. For example, sales by city, revenue by product, profit by department, customers by country. Grouping allows businesses to compare performance across categories. Real-world business example. Imagine you are a data analyst in an online shopping company. The manager asks, I don't need every order. Just tell me. Total sales. Average order value. Number of customers. Best-selling category. Instead of showing millions of rows, you provide a clear summary. That's exactly what aggregation is designed for. Common beginner mistakes. Many beginners focus only on individual rows. Forget to summarize data. Don't understand when grouping is needed. Think analysts mostly retrieve data. In reality, analysts spend much of their time summarizing data to support business decisions. Key takeaways. Aggregation summarizes large amounts of data. Businesses use summaries to make decisions. Count answers how many. Sum answers what is the total. Average answers what is the average. Max answers what is the highest. Min answers what is the lowest. Group by creates categories before calculating summaries. Question of the day. Imagine you own a restaurant. What is the first summary you would want to see every evening? For example, total sales, number of customers, most popular dish, average bill amount. Share your answer in the comments. Next episode. In the next episode, we'll learn filtering theory, how databases decide which data to keep, which data to ignore, and why filtering is one of the most important skills for every SQL professional. SQL Theory in Reverse Order, Episode 7. Title: Filtering Theory Explained. Vertical bar. How SQL finds exactly the data you need. Introduction. Welcome back. Imagine a company has 100 million records. Do you want to see every single one? Probably not. If your manager asks, show only customers from Hyderabad. Show only orders placed this month. Show only products that are out of stock. You need a way to remove all the unnecessary data. This process is called filtering. Filtering helps us focus only on the information that matters. What is filtering? Filtering means selecting only the records that meet certain conditions. Think of it like using a search filter on an online shopping website. You might choose price below 1000 rupees. Brand Samsung. Rating 4 stars and above. Instead of seeing thousands of products, you see only the ones that match your needs. SQL filtering works in the same way. Why filtering is important? Businesses rarely need all the data. They usually ask specific questions such as: which customers made purchases today? Which employees worked overtime? Which products are low in stock? Which students scored above 90%? Filtering helps answer these questions quickly and accurately. Where filtering individual records. The where concept is used to remove individual records that don't match a condition. Imagine a teacher wants to see only students from class 8. The teacher doesn't look at every student in the school. Instead, only class 8 students are selected. That's the idea behind filtering individual records. Having filtering groups. Earlier, we learned about grouping data. Sometimes, after creating groups, we only want to keep certain groups. Imagine a principal asks: show only classes where the average marks are above 80. First, the students are grouped by class. Then, only the groups that meet the condition are kept. This is the idea behind filtering groups. Where versus having. This is one of the most confusing topics for beginners. Here's an easy way to remember it. Where works before data is grouped. It filters individual records. Having works after data is grouped. It filters entire groups. Think of it like this. Where chooses which students enter the classroom. Having decides which classrooms remain after calculating the class average. Logical conditions. Businesses often combine multiple conditions. For example, customers from Bengaluru and who purchased this month. Employees from the sales department or the marketing department. Products that are not discontinued. Using logical conditions helps answer more specific business questions. What about missing information? Sometimes data is incomplete. For example, a customer forgot to enter a phone number. An employee's manager hasn't been assigned yet. A delivery date hasn't been recorded. Databases represent missing information using null. Understanding missing data is important because it behaves differently from normal values. Real-world example. Imagine you are working for an online shopping company. Your manager asks: show only orders placed this week by customers from Karnataka. Without filtering, you'd have to search through millions of records. With filtering, the database quickly narrows the results to exactly what's needed. This saves time and improves decision-making. Common beginner mistakes. Many beginners forget to filter data before analyzing it. Confuse where and having. Ignore missing values, null. Retrieve far more data than necessary. Professional analysts think carefully about which data is actually needed before writing a query. Key takeaways. Filtering means selecting only the required data. Businesses use filtering to answer specific questions. Where filters individual records. Having filters grouped results. Logical conditions make filtering more powerful. Null represents missing information and requires special attention. Question of the day. Imagine you are a data analyst for a hospital. What would you filter first? For example, patients admitted today. Doctors on duty. Available beds. Emergency cases. Share your answer in the comments. Next episode. In the next episode, we'll learn sorting theory, how databases organize results from highest to lowest, oldest to newest, and why sorting helps businesses make better decisions. SQL Theory in Reverse Order, Episode 8. Title: Sorting Theory Explained. Vertical bar: how SQL organizes data like Google, Amazon, and Netflix. Introduction. Welcome back. Imagine you search for wireless headphones on an online shopping website. Thousands of products appear. Would you want to see them in a random order? Probably not. Instead, you choose options like price, low to high, price, high to low, best selling, highest rated, newest arrivals. This is called sorting. In SQL, sorting helps organize data so it's easier to understand and use. What is sorting? Sorting means arranging data in a meaningful order. Instead of displaying records randomly, the database organizes them based on one or more columns. Sorting makes reports cleaner, easier to read, and more useful for decision-making. Why businesses need sorting? Businesses constantly ask questions like: which product sold the most? Who is the highest paid employee? Which customer spent the most? What are today's latest orders? Which students scored the highest marks? Without sorting, finding these answers would be difficult. Ascending order. Ascending order means arranging values from smallest to largest. Examples: numbers 10, 20, 30. Prices 100 rupees, 500 rupees, 1000 rupees. Dates oldest, newest. Names AZ. Ascending order is useful when you want to see the smallest, earliest, or alphabetically first values. Descending order. Descending order means arranging values from largest to smallest. Examples: revenue, highest, lowest. Marks, highest, lowest. Salary, highest, lowest. Dates, newest, oldest. Names ZA. Business dashboards often use descending order to highlight the most important results first. Sorting by multiple columns. Sometimes one level of sorting isn't enough. Imagine a school report. Students are first sorted by class. Within each class, they are sorted by marks. Businesses use this approach too. For example, department salary, country city, category product name. This creates a more organized and meaningful report. What is limit? Sometimes businesses don't need every record. Imagine your manager asks, show me the top 10 highest selling products. The manager doesn't want thousands of products. They only want the most important ones. That's where the idea of limiting results comes in. It helps display only the required number of records. Real-world examples. Sorting is everywhere. Google ranks search results. Amazon sorts products by price, popularity, or ratings. Netflix recommends trending movies. Food delivery apps sort restaurants by distance or reviews. Banks sort transactions by date. Hospitals prioritize patients based on urgency. Sorting helps users find the most relevant information quickly. Common beginner mistakes. Many beginners forget to sort reports. Display data in random order. Use the wrong sorting direction. Ignore the importance of showing the most useful information first. Professional analysts think about how decision makers want to see the data. Key takeaways. Sorting organizes data into a meaningful order. Ascending order arranges data from smallest to largest or A to Z. Descending order arranges data from largest to smallest or Z to A. Multiple levels of sorting make reports easier to understand. Limiting results helps focus on the most important records. Question of the day. Imagine you are the CEO of a company. Which report would you check first? Top 10 customers. Top 10 products. Top 10 employees. Top 10 cities by sales. Tell me your answer in the comments. Series recap. So far, you've learned how experienced data analysts think, how SQL executes behind the scenes, optimization, database design, joins, aggregation, filtering, and sorting all without writing any SQL code. You are building the mindset that professional data analysts use every day. Next episode. In the next episode, we'll explore data types theory, why databases store numbers, text, dates, and other kinds of information differently, and how choosing the right data type improves accuracy and performance. SQL Theory in Reverse Order, Episode 9. Title: SQL Data Types Explained Vertical bar the hidden foundation of every database. Introduction. Welcome back. Imagine you are filling out an online registration form. One box asks for your name. Another asks for your age. Another asks for your date of birth. Another asks whether you are already registered with a simple yes or no. Would it make sense to enter your name where your age should go? Of course not. Databases work the same way. Every piece of information has a specific type, called a data type. Choosing the correct data type helps keep data accurate, organized, and efficient. What is a data type? A data type tells the database what kind of information a column can store. Think of it as a label that says, this column stores names. This column stores numbers. This column stores dates. This column stores true or false values. Without data types, databases wouldn't know how to store or process information correctly. Why data types matter? Imagine a company stores salaries as text instead of numbers. Can the database correctly calculate total salaries or average salaries? No. If dates are stored as plain text, can the database easily find all orders placed this month? Again, no. Choosing the right data type makes calculations, sorting, filtering, and reporting much easier. Text data. Text data stores words and sentences. Examples include customer names, product names, email addresses, city names, phone numbers. Even though a phone number contains digits, it's usually stored as text because we don't perform mathematical calculations on phone numbers. Numeric data. Numeric data stores values used for calculations. Examples include price, salary, age, quantity, marks, revenue. Databases use numeric data to calculate totals, averages, profits, and many other business metrics. Date and time data. Many businesses rely on dates and times. Examples include order date, joining date, delivery date, payment date, login time. Using a proper date data type allows databases to answer questions like what happened today? Which orders were placed last month? How many customers joined this year? Boolean data. Sometimes the answer is simply yes or no. Examples include payment completed, student passed, product available, email verified, customer subscribed. A Boolean data type stores these two possible values efficiently. Null missing information. Sometimes information isn't available. For example, a customer hasn't entered a phone number. A product doesn't have a discount yet. A delivery date hasn't been assigned. Instead of guessing or storing incorrect information, databases use null to represent missing data. Null doesn't mean zero. Null doesn't mean an empty word. It simply means the information is currently unknown or unavailable. Choosing the right data type. A good database designer asks, will this column contain words? Will it contain numbers? Will calculations be performed? Does it represent a date? Is it simply yes or no? Can the value sometimes be missing? Choosing the correct data type improves accuracy, saves storage, and makes the database faster. Real-world example. Imagine you are designing a student database. You might store student name text, roll number, date of birth date, fees paid yes no, admission date, parent phone number text. Each column has a purpose, and selecting the correct data type helps the database work efficiently. Common beginner mistakes. Many beginners store numbers as text, store dates as plain text, misunderstand the meaning of null, choose the wrong data type for business data. Professional database designers think carefully about the type of information before creating a table. Key takeaways. Every column has a data type. Data types tell the database how to store and process information. Text stores words and labels. Numeric types store values used in calculations. Date and time types store time-related information. Boolean stores yes, no or true, false values. Null represents missing or unknown information. Question of the day. Imagine you are creating a database for a hospital. What data types would you use for these columns? Patient name, age, admission date, blood group, bill amount, discharged. Write your answers in the comments. Next episode. In the final episode of this theory series, we'll answer the biggest question of all. What is SQL, and why has it remained one of the most valuable skills in data analytics for decades? After that, we'll be ready to start learning SQL practically with a much stronger understanding than most beginners. SQL theory in reverse order, Episode 10, Final Theory Episode. Title: What is SQL? Vertical bar why SQL has been the number one data skill for over 50 years. Introduction. Congratulations! If you've watched all the previous episodes, you've already learned how professional data analysts think before writing SQL. You now understand how databases are designed, why joins are needed, how filtering works, how data is grouped and summarized, why sorting matters, why data types are important, how databases optimize queries. Today, we'll answer the biggest question. What exactly is SQL, and why is it one of the most valuable skills in the world of data? What is SQL? SQL stands for Structured Query Language. It is the standard language used to communicate with relational databases. Think of SQL as the language humans use to ask databases questions. The database stores information. SQL helps us retrieve, organize, update, and analyze that information. What is a relational database? A relational database stores information in related tables. Instead of placing everything in one giant table, data is organized into multiple connected tables. For example, customers, orders, products, employees, payments. These tables are connected using relationships, allowing businesses to manage millions of records efficiently. Why is SQL so important? Every second, businesses generate enormous amounts of data. Examples include online shopping, banking transactions, hospital records, airline bookings, school management, food delivery, mobile apps, social media. Without SQL, finding useful information from this data would be almost impossible. SQL transforms raw data into meaningful insights. Who uses SQL? SQL isn't only for software engineers. Many professionals use it every day, including data analysts, business analysts, data scientists, database administrators, software developers, machine learning engineers, product analysts, business intelligence developers. Even managers often understand basic SQL to make better business decisions. What can SQL do? SQL allows us to retrieve information, filter records, sort results, combine multiple tables, calculate totals and averages, update existing data, add new records, remove unwanted records, create new tables, manage databases. It is much more than just searching for data. Why has SQL survived for so long? Technology changes rapidly. Programming languages come and go. But SQL has remained popular for decades because it is simple to learn. It is powerful. It is reliable. Almost every major company uses relational databases. It works across many database systems with only small differences. That's why SQL continues to be one of the most valuable technical skills. The biggest mistake beginners make. Many beginners try to memorize SQL commands. Professionals focus on understanding the business problem first. Remember this simple formula. Business question database thinking SQL query business insight. If you master this approach, learning SQL syntax becomes much easier. What you've learned in this series. You now understand how senior data analysts think. SQL Execution Order, Query Optimization, Database Design, Primary Keys and Foreign Keys, Join Theory, Aggregation, Filtering, Sorting, Data Types. The purpose and importance of SQL. You have built the mindset that experienced analysts use before writing code. What's next? Now it's time to start writing SQL. In the practical series, we'll learn select, from, where, order by, limit, distinct, aggregate functions, group by, having, joins, subqueries, common table expressions CTEs, window functions, real-world business projects, interview questions, SQL for FANG data analyst roles. We'll continue using simple explanations and practical business examples. Final motivation. Don't rush to memorize SQL. Understand the logic behind databases. Once your thinking becomes clear, SQL becomes much easier. Remember, great data analysts don't just write SQL, they solve business problems. That's the mindset that will help you grow in your career. If you've completed all 10 theory episodes, congratulations. Comment below. I completed the SQL theory series. I'd love to celebrate your progress with you. If this series helped you, like the video, subscribe to the channel, and share it with someone who wants to become a data analyst. See you in the practical SQL series, where we'll turn this knowledge into real skills.